Hello everyone. We will be presenting our final project title Academic Certificate Anti-Fraud Blockchain System. My name is Vrund Patel.
And I'm Jinit Suthar. Together, we developed a complete end-to-end blockchain-based system that issues, secures, and verifies academic certificates using cryptographic techniques and our modified class blockchain implementation.
In this presentation, we will talk through the problem of certificate fraud, the algorithm we used, the system architect, our demo workflow, and how we divided the work equally. So, moving on to the next slide. The core problem we wanted to address is the risk of academic certificate fraud. Employers increasingly receive forged degrees, and universities still depend on slow manual verification processes. So, we built a permissioned blockchain system where universities digitally sign certificates and the system generates a SHA-256 hash of each PDF, storing that hash on the blockchain. This ensures the document is tamper-proof. Students access their certificates through a wallet-like panel, and employers verify authenticity simply by uploading the PDF. The entire platform is built using Python Flash, RSA digital signatures, SHA-256 hashing, HTML templates, and an extended version of our class blockchain code. Moving on to the next, let's look at the algorithm behind our system. We use RSA digital signatures so that only authorized universities can issue certificates. The university signs certificate details with its private key, and the blockchain nodes verify using the public key. Second, we integrated SHA-256 hashing. Every uploaded PDF is hashed, and this hash is stored on the blockchain. When an employer uploads a certificate during verification, the system hashes the file again and compares the hashes. We also extended the class blockchain data model. Each blockchain now stores a list of certificate records along with its timestamp, nuance, and previous hash. Finally, the proof of work mechanism remains from the class code as it is. It demonstrates tamper resistance and ensures blocks cannot be altered without remining the entire chain. Together, these algorithms support the integrity, immutability, and decentralization required in our research analysis.
Now, moving on to system flow, workflow, and demonstration, the university panel allows universities to generate keys, upload a certificate PDF, enter student details, and submit a certificate. The system automatically hashes the PDF and creates an RSA signature. The blockchain node receives the certificate, verifies the signature, stores it temporarily in the pending pool, and then includes it in a newly mined block. Students use the student wallet panel where they enter the public key and view all certificates issued to them. They can also download the original PDF as well. Employers use the verification page where they upload the student's PDF. The system hashes it again and checks it again in the blockchain. If the hash matches, the certificate is valid. If not, it it is flagged as tempered or invalid. Finally, the PDFs remain off chain for privacy, and only the hash is stored on blockchain to ensure security while preventing data exposure. So let me showcase these in our demonstration. Here is the wallet generator that we implemented in the class. I have kept it as same as the class one. So let me generate a new wallet and copy the public key. Here in the certificate issue page, we can upload university's public key, university's private key, as well as student's public key, which I'm uploading right now. We can enter the student's name, the degree, and the major as well. So we can also add the date of issuing, let's say 10th November, and we can choose a file or image of the certificate. For example, I'm choosing this image and we can generate the certificate. It will give you a confirmation page that shows every detail that we entered in earlier, as well as certificate hash and signature, and the blockchain node URL as well. We can confirm the certificate, it is submitted, and it will be shown on the node. Here, once you refresh, you can see that the transaction is pending right now. And once we finalize the block, it will be added to our chain. So when we go back to our issuing certificate, we can go to view certificates page and copy the node URL link and enter view certificates. So it will show us that there are two certificates. One I added earlier for demonstration, the second that we add right now. And it will show students public key, university public key, as well as certificate hash. In the employer verification page, you can add a blockchain's node URL and choose the file. We can upload the certificate image or PDF and verify the certificate. It will give you certificate hash, the number, blockchain numbers, as well as student's name and degree and major and everything. I uploaded the same image as I did earlier, so that is why it is giving me the details from earlier. And I can download that certificate here, and once you do open, it will show you the page as well. Then we can go to student wallet, enter the blockchain node URL, and copy student's public key. And once we paste it, it will load the information about the certificate. It will show degree, major, date issued, university public key, certificate hash, as well as a download PDF button to get that certificate. As you can see, it is working again. And that concludes my presentation. Here, let's see workload division.
Now, moving on to our workflow division, we contributed equal to the entire project, each completing 50% of the work. I completed research question 1 to 5, including the use case justification, blockchain sustainability, algorithm selection, risks, and ethical consideration. On the implementation side, I developed the RSA signing logic, the SHA-256 PDF hashing function, and the certificate creation endpoint. For my part, I worked on the backend logic, especially the hashing and certificate creation pipeline. I'll show you two simple code part I handled. First is certificate creation endpoint, client to node side. This code sends the certificate data from the client side to the blockchain node. It includes the student details, the PDF hash, and the digital signature. This is how a new certificate request officially enters the blockchain. The second one is SHA-256 hashing for uploaded PDFs. This function creates the SHA-256 hash of the uploaded PDF. It turns the PDF into a unique fingerprint. It even on it like even if one small thing changes in the PDF, the hash becomes completely different. This is why this is what lets us detect tampering.
My work focused on verification side, the UI screens, and the blockchain node signature validation. And I completed research questions 6 to 9, covering adoption barriers, scalability, stakeholder analysis, and why the proof of work class model is appropriate for this assignment. For development, I built the student wallet panel, the employee verification page, the verification endpoints, the RSA signature verification logic, and designed much of the UI. I'll show you two key code parts that I handled. First is RSA signature verification of the blockchain node. This code verifies that the certificate was actually signed by the university. It uses the university's public key to check the signature. If the signature is fake, the blockchain node rejects the certificate. Second, student wallet panel, fetching certificates. This endpoint retrieves all certificates belonging to a specific student. It works like a small wallet where each student can view everything issued to them.
Together, we completed testing, debugging, and validating all the endpoints.
We also collaborated on documentation, architecture design, and final presentation preparations. Finally, here are the references that we used. We relied on foundational blockchain material such as Bitcoin white paper, RSA labs documentation, niched hashing standards, and published academic implementations like MIT's blockchain certificate project. We also use documentation for Flask and Pi- uh, PyCryptodome, as well as instructions provided for for this final project. These references ensure our approach stayed technically accurate and academically credible. That concludes our presentation.
Thank you for listening.